This is a lesson for the first day of not only introducing complex numbers, but also working with simplifying them. Today we're going to add, subtract, and multiply complex numbers. In a later lesson, we'll divide them. So we're going to work through an example that helps motivate the reason for complex numbers. We're going to talk through some notes, and then you will go through some of the book examples, looking at example 2 and example 3, and then work on your homework for this lesson. So let's do these AB examples here for you. First of all, when you look at these two, you want to figure out for what x values is this a true statement. So most of the time you look at this and say, hey, I want to take the square root of both sides to get the answer. Well, we take the square root of x squared, and we're going to get an x. And then the square root of 16, we're going to get a 4. But you have to remember that not only does 4 squared equal 16, but also negative 4 squared equals 16. So you have to remember when you do these solving problems and you take the square root of both sides, you have to include a plus or minus to get both answers. Now on this one, we're going to have the same idea, only when we take the square root, you're going to have plus or minus the square root of negative 9. The problem is, up to this point in working with different problems, you've never worked with square roots of negatives. So that's what we're going to do. The motivation for this is, if we have a negative number underneath the square root, we want to introduce a new numbering system that will help us do those problems. And it's called complex numbers. So let's go ahead and take some notes. So if you take out your note sheet and then fill this in as we go. First of all, we want to talk about why we have imaginary numbers. And just like I mentioned here, we have imaginary numbers to find the square root of negative numbers. That's the motivation. Imaginary numbers are a new numbering system that are part of complex numbers that we'll talk about today. So the key idea is that the letter I, when we use it, is going to represent the square root of a negative. Square root of negative 1, we'll take out the square root of negative 1 and replace it with the letter I. That's called the imaginary unit. Okay, so this is the foundation of what we're going to do. This is called the imaginary unit. All right, so let's do a couple quick examples. Okay, first example, if we want to do like on the last problem we just did, we want to do square root of negative 9. What we do is we separate this into the square root of negative 1 times the square root of 9. And then that gives us square root of negative 1 is I, square root of 9 is 3, and we usually list the I second, the 3 first. So even though I is not a variable, it often looks like when we did 3x or 3y, it is a constant, but you're going to treat it the same way. All right, so another example would be, what about the square root of negative 16? Well, again, negative 16, we'll take out the square root of negative 1 times the square root of 16. And that gives us the square root of negative 1 is I times 4. That equals 4I for that. All right, you try one. Try doing the square root of negative 100. See what you get. So pause the video, try that, and then come on back. Hopefully you tried that. You took the square root and separated out the square root of negative 1 times the square root of 100, and that gave you 10I for an answer. Okay, so now we're going to take these imaginary numbers that we have involving the I, and we're going to talk about what are called complex numbers. Complex numbers have a real part. This is like the real numbers that you've dealt with. and then we have an imaginary part, what we're just working with here, that has an I involved in it. So examples of imaginary, of complex numbers, an example would be, for instance, if we had 3 plus 5i. The 3 is the real part, the 5i is the imaginary part. If we had, for instance, 0 plus 2i, which is the same thing, if we wanted to, we could just write that as 2i. That's a complex number 2. Real part 0, imaginary part's 2i. And then we could have a number like 17 plus 8i. Okay, so we have the real part, the imaginary part is part of that answer. Okay, so let's go ahead and see how we work with these. We're going to talk about addition, subtraction first for these complex numbers. So initially you want to be thinking about combining like terms. Just like you do with x's and y's, you want to combine like terms. So here's an example. If we wanted to do a problem like this, 7 plus 2i, and then we're going to add to it 12 minus 3i. 12 minus 3i. Now, you look at these, and all you have to do, like you would do with x's and y's, add the ones that don't have i's, and add the ones that do have i's. So 7 plus 12 would give me 19. Adding the real parts, now add the imaginary parts. 2 plus the negative 3i would give me negative 1i. So there's my result, that's a complex number. Let's try another one. This one we'll do subtraction. Let's do 20 plus 4i and subtract 15 plus I. Now, I'm going to tell you on this one, you got to remember that the negative goes for both of them. So when I do this, I'm going to take 20 minus 15, that's going to be equal to 5. And then I'm going to do 4i minus 1i, it's going to be 3i. My answer. So combining like terms when you add or subtract. Now let's talk about multiplication. We'll turn to division later. So let's just do multiplication at this point. So division, this will be a later lesson. Focus on multiplication. This is going to look a lot like what we were doing with when we were dealing with double distributive property for our binomials. So in this one, we're going to take and do like 5 plus 3i and multiply times 7 minus 2i. Now in our double distributive, you're going to go 5 times 7 is going to be 35. And then we're going to do 5 times negative 2i, that's going to be negative 10i. And we'll do 3i times 7, that's plus 21i. And then 3i times negative 2i is negative 6. Now here's something different. I times I is I squared. Now here's what we have to do with this. I squared is something unique in what we do on these problems. Let's think about what that means. If I take I, which is the square root of negative 1, and I square it, the square gets rid of the square root, and that turns it into a negative 1. The square gets rid of the square root. So I squared is going to equal negative 1. Put a box around this. This is going to be something that we use a lot when we deal with imaginary numbers. If you see an I squared, substitute it out and put it into negative 1. So this is going to be 35 minus 10i, these two are alike, plus 21i. If I add those two like terms, that's going to be plus 11i. And then negative 6 times negative 1. If if I combine those two, I'm going to get 35 plus 11i plus 6. 35 plus 6 is equal to 41 plus 11i. So that's my final answer for it. All right, let's have you try one. So try this problem. Let's do 8 plus 2i times 10 plus 3i. Okay, you try multiplying those. Pause the video, try multiplying that through, simplifying it, and then see what you get. And then we'll do it together. So pause the video. Now that you've tried it, let's do it together. I'm going to get 8 times 10 is 80. 8 times 3i is going to be plus 24i. 2i times 10 is 20i. And then 2i times 3i is going to be 6i squared, with a positive. Now, I'm going to combine these two middle terms, and I'm going to recognize that this is a negative 1 times 6. So what I get is 80 plus 44i, and then this will be a minus 6, because we got 6 times negative 1 gives me a negative. And then 80 minus 6 will give me 74 plus 44i. Multiply those two together. Hopefully that's what you got when you did this. All right, now let's put this into context and then go back and finish the problem we started out with. So let's talk about what the number systems are that you're dealing with. So these are number systems that you've dealt with before, you've had in math. This is the new number system for this context. So a brand new number system for us. Complex numbers are in the form of a plus bi. The imaginary numbers are based on negative 1, square root of negative 1 equals I. And this is the bi part of it. The real part is a. Those are all the numbers you've dealt with. For instance, you've dealt with rational numbers. This is the word ratio, which means it can be written as a ratio of 2 integers. As an example, 5/4. Another example would be 1/3. All of these numbers that we write as rationals can be written as a decimal that either stops, like 1.25, or repeats, 0.3 repeating. That's what they all do. Now, irrational numbers, on the other hand, those decimals never end, they go on forever, and they never repeat. One example you might be thinking of that you've used for quite a bit is the number pi. 3.14159, it goes on forever, never repeats. Another example of an irrational number is a square root of a number that you can't get rid of. Square root of 5, I don't know the square root of 5, it becomes irrational. Now if I had the square root of 16, that number's 4, that can be a rational number. I can list as 4/1. But square root of 5, if it can't get rid of the square root, it's irrational. And then integers, these are numbers like, for instance, -5, -4, and you just keep going. You go to 0, 1, 2. They're all your counting numbers and all their negatives as part of that. All right, so that's a basic idea of how we're using complex numbers. So back to this problem was where we got stuck. Remember, we couldn't do the square root of a negative. We now can solve this problem because we can now say that we take out the square root of -1 times the square root of 9, and we get for this problem plus or minus 3i as the answer. So, a couple summary items for you. The key ideas to remember are to, when you're looking at complex numbers, the imaginary part is based on the square root of -1 equals I. That's a key idea. And that if you square I squared is equal to -1. We're going to use that quite a bit. And when you deal with complex numbers, you've got a real part and imaginary part, so it looks like a binomial, add the real parts together like we did here on these problems. Add the real parts together, add the imaginary parts together to get your answer. Or if you're multiplying, go ahead and do the double distributive in order to get your answer, simplify it to finalize it. So complex numbers opens up a whole world of other mathematics that we can do that involves the square root of negatives.